Welcome to Next Gen Manufacturing Nexus, where we dive deep into the systems that build and power our modern world. So let's get right into it. You hear the word engineer all the time, right? And it probably brings up images of hard hats, complicated blueprints, maybe some heavy machinery. But what does an engineer actually do all day? What are the real problems they get paid to solve? Today, we're going to break down what it really means to be an engineer, from the factory floor all the way to the digital cloud.
No, seriously, just take a second and think about it. When I say the word engineer, what's the first image that pops into your head? For a lot of us, it's probably someone sketching out a futuristic car or maybe designing a massive bridge. And you know what? You're not wrong, but that's just one tiny piece of a much, much bigger puzzle.
So let's start there, with the engineer that you probably pictured, the automotive designer. This role fits that classic image perfectly, doesn't it? These are the folks shaping the slick, powerful cars we see on the road every single day. It's tangible, it's cool, and it's the perfect place for us to start our journey.
So let's imagine a day in the life of Tamer, our car engineer. His day is this really cool mix of teamwork and intense focus. He might start off in meetings looking at these incredible computer models of new designs. Then he's off to the testing center to watch a crash test. Yeah, a little intense, but absolutely crucial for making cars safe. Then his afternoon is probably spent glued to a computer, using some seriously powerful software to design everything from the engine down to the lug nuts, making sure every single part works together flawlessly.
Okay, so Tamer's job is pretty much what we all thought it was. But is engineering really just about designing shiny new things from scratch? Not even close. See, at its absolute core, engineering is about solving problems. And some of the most important engineering work isn't about building something new. It's about making the things we already have work a whole lot better.
So let's step out of the design studio and onto the factory floor. Here, the big problem isn't what cool things should we build, it's how can we build this thing without wasting time, money, or materials. Welcome to the world of the production engineer. And what's so fascinating here is the contrast. You've got this before and after picture. On one side, you have a messy, wasteful process where things are kind of done differently every time. It's chaotic. On the other, you have a lean, streamlined system. And that is the holy grail for every production engineer. Their entire job is to hunt down every last drop of waste in the manufacturing process and just eliminate it. And they have some brilliantly clever tools for this. My favorite is a Japanese concept called Pokoyoke, which basically means error-proofing. It's all about designing a process so that it's literally impossible to mess up. Think about a USB cable that only fits one way. That's Pokoyoke. Or a microwave that won't start if the door is open. It's genius, simple, and it's a production engineer's best friend. And this image shows you just how deep they go. A production engineer doesn't just tweak a machine. They engineer the entire human process around it. I mean, look at this. This isn't just a simple to-do list. It is a meticulously designed system. The level of detail is insane. Every single task is spelled out to make the process so repeatable, so foolproof, that there's simply no room left for error. Okay, now for a big shift. Let's see how these exact same ideas apply when we move from a physical factory to a digital one. Because in the world of software, the production line is invisible, right? It's just code, servers, and networks running all the apps we use. And when this digital factory breaks down, a totally different kind of engineer gets the call. The big problem here is what one engineer on Reddit perfectly described as the deployment wall. This is the invisible barrier between the developers who are writing cool new features and the operations team that has to keep the whole system from crashing. Pushing new updates is super risky. One bad line of code could bring everything down for millions of users. And that's where the Site Reliability Engineer, or SRE, comes in. These are basically the production engineers of the cloud. They are software engineers who tackle this problem by treating the operation of a system as its own engineering challenge. They build automated systems and processes to make sure that deploying new software is smooth, safe, and totally reliable. Now check this out. This diagram shows a system called Overton, and you can think of it as a fully automated digital factory, but for machine learning. It handles the entire process, from training a new AI model to deploying it live. SREs build and manage these unbelievably complex systems, making sure that digital production line is always humming along. It is the exact same problem-solving mindset we saw on the factory floor, but the entire factory is built out of code. All right, for our last example, let's go from the clean, abstract world of code to one of the most physically demanding, high-stakes environments on the entire planet, an oil field. Here, the problems are massive, they're messy, and a single mistake can have enormous financial consequences. I absolutely love this quote from a petroleum engineer. It just gets right to the heart of what they do. It's not about just pumping as much oil out of the ground as possible. No, it's a constant high-stakes economic balancing act. Every single decision is weighed against its cost and its potential to make money. They're optimizing a giant financial system that just happens to be disguised as a bunch of wells.
So their day is basically a masterclass in high-tech diagnostics. They're like a doctor for an entire portfolio of wells. They start the morning hunting through data for any signs of trouble, any little drop in production. They're analyzing pressure, flow rates, managing complex chemical cocktails to keep the whole system from clogging up. They even do autopsies on failed metal parts to figure out what went wrong. It's a nonstop battle against physics and geology to keep the money flowing.
Okay, so we've met the car designer, the factory optimizer, the cloud engineer, and the petroleum production engineer. I mean, these people work in wildly different worlds, so what on earth could they all have in common? Well, it turns out they're all united by a shared mindset and the same universal toolkit for thinking. It really all boils down to these three things. Number one, at the very top, is problem solving. That's the absolute core of what an engineer does. Right behind it, you have analytical skills, that ability to look at a ton of data and a complex system and figure out what's really going on. And third, process improvement, that relentless drive to not just fix a problem for today, but to make the whole system better so that problem can never happen again. And they apply these skills using a very specific structured method. It's often called root cause analysis. See, instead of just putting a bandage on a problem, engineers are trained to dig and dig and dig. They clearly define what's wrong, they collect all the data they can, they brainstorm all the possible causes, and then they test things one by one until they find the true root of the issue. Only then do they build a solution, making sure they've killed the problem for good. So at the end of the day, what does an engineer really do? They are professional problem solvers. That's it. Whether that problem is building a safer car, cutting waste in a factory, keeping your favorite app online, or squeezing more value out of a multi-million-dollar oil field, the fundamental approach is exactly the same. They are the people who look at our complex, messy world and systematically make it work better, one solved problem at a time. The only real question is, what problem will they solve next?